Okay, this is a PPT. Now here we can consider all the different types of forces as fundamental forces of the universe. Now yesterday we had seen about the video regarding forces. Now force is considered as a push or pull. Now using that we can move the objects. Now here we are going to see about the different types of concepts regarding forces. Now forces are classified into 4 types. So those 4 types of fundamental forces we have to refer in today's class. So let us see the first slide. Okay, basically we are having 4 different types of forces, fundamental forces. Now if you consider which one is stronger and which one is weaker, so here there is a arrangement you can see in this particular slide. So on the top you are having strong force, the strong force here, it is regarding the nucleus. So we call it as the strong nuclear force. So out of these 4 types of forces, the top one is the strongest force. Okay, if you are moving downwards here, the second one is the electromagnetic force, and the third one weak nuclear force, and the fourth one gravitational force. Now here we had arranged the 4 types depending on the amount of force. Okay, so basically in your previous studies you might have studied gravitational force, electromagnetic force, strong force, and nuclear force. The sequence might be different. Now here this slide shows which one is stronger and which one is weaker. Okay, so this is a shortcut to identify about the amount of force. So I'm repeating once again. This particular slide shows 4 types of forces. Which one is stronger out of these 4 means it is a strong nuclear force. Second is the electromagnetic force. Third one is weak nuclear force, and fourth one is the gravitational force. Now let us go with the next slide. So just this is the introduction only. I had written notes in a different format. Okay, let me show what I had wrote in the notes. Okay, now here, depending on the previous video, you can start the points of force here. Okay, points, important points regarding the force. Now here, what is a force? Force is defined as push or pull. Okay, this we had seen in the video also in the yesterday's class. Okay, force is a push or pull. Let me change the color. Okay. Okay, now here this is push or pull, which is considered as a force here. Now, what is the purpose of this force? If you ask a question like that, then depending on the force, if you apply the force, what happens? You can change the state of the body. You can change the state of the body. So if a body is at rest, yesterday you had seen 2 cases. A football is there, which is at rest. Okay, and in the second case, it is moving with some constant velocity. Now, if it is at rest, you can move this football by applying a force. Okay, so a body which is at rest can be moved. Now, if a body is already moving with some constant velocity, if you apply the force on that particular moving body, what happens? You will have the concept of change in the velocity. So it will change in the amount of velocity. Nothing but if it is moving with some 2 meters per second, if you apply a force which is in the same direction, then what happens? The speed of that particular body will increase. Okay, so depending on those things, we had given effects of a force as the next important point. Okay, first point we had explained about what is force. So what is actually force? Force is nothing but push or pull. So what is the purpose of a force? We can change the state of the body. Now, what are the effects of a force? Okay, that we are covering in these 3 points. So here the first point we had covered that a force can change the speed of a body. Either you can increase the speed or decrease the speed. That is the first point, first effect of the force. Now the second point or the second effect, a force can change the direction. Suppose if you are playing the football, okay, if you are playing the football game, then what happens? Depending on the amount of force and the direction which you had applied, this football can be moved in either of the directions, okay, according to your requirement. So that is the thing here. A force can change the direction of motion of a body, moving body. Okay. Next, the third point, third important point, a force can change the shape and or size of a body. Suppose a sponge is there. Suppose if a sponge is there, if you consider this as a sponge, okay, this is at rest. Now if you apply a force on the top side, okay, if you consider this as a sponge, now what happens? The size of this particular sponge will reduces. What is the reason? You had applied a force here. Okay, so here what is the point here? You can change the shape as well as size of the body. So this is one of the example. Here I had considered sponge. Okay, similarly you can apply any of the example. So what are the 3 important effects that can be covered under force means? The first point is a force can change the speed of a body. Either you can increase or decrease that particular speed depending on the amount of the force. Now the second point is you can change the direction of the motion of a moving body. Third important point is that you can change the shape and or. Okay, so depending on your requirement, if you want to change only shape, okay, you can apply certain amount of the required force. If you want to change the shape, the amount of force may change. If you want to have both the changes, okay, then the concerned force should be there. Okay, so either you can change any one of these two or you can change both these two. Okay, so now those are the important introductory part of the force. Now let us see the different types of forces that usually we will find in the textbooks. Okay, now this will be the sequence that you had that you might have seen in your textbooks. So initially you will start with the gravitational force, next electromagnetic force, strong force, and weak interaction force. Okay, so strong force and the weak force are regarding the nuclear concepts. Okay, nothing but the microscopical view. Okay, now that is shown here. So in this particular slide we are speaking about nuclear force, which is strong. Let us go with the previous slide here. Okay, so out of those forces we had arranged the sequence here. Which one is stronger? The first one here we had mentioned it as a strong nuclear force. That one is stronger among all the four. Okay. So which one is next stronger? Okay, that is electromagnetic force. So next one is weak nuclear force, and the last is a gravitational force, depending on the amount of strength of that particular force. Okay. Now let us see few points regarding the strong force. Okay. Now here we are mentioning the nuclear force here itself. Nuclear force. So the nucleus, the force that is holding the nucleus. So what is there inside the nucleus? You can find the electrons, protons and neutrons. So how the atom is there? Okay, how the atom is holding all those things. So it is depending on a force. So that particular force will be stronger. If you refer to one of the metal, take a metal. Let us take iron. So how the iron piece is stronger means it is depending on the amount of nuclear force that is available inside the atom. Okay, so that is why we are considering the nuclear force as the strongest force among all the four. Okay, so now the next point, even though it is very stronger, okay, so here we are saying it is very stronger, but what is the range? The range will be very shorter. What is the reason? We are saying that this particular force is related to the nucleus. So where is nucleus here? It is inside the atom. So if you consider the atom is very smaller. Okay, that's why even though this particular force is stronger when compared with all the three remaining forces, the range will be very shorter. Okay, that is our second point that you need to consider. First point is it is holding the nuclei of atom together. Second point is it is very stronger, but only over very short distances these forces will exist. Now let us go with the next slide. Now electromagnetic force. So what is electromagnetic force that you might have studied in your intermediate also? So this is the cause of electric and magnetic effects. Okay, you might have seen certain charges. The charges will be either positive or negative charges will be there. Now between like charges, if you take two positive charges at a time, what happens? There will be some force of repulsion. If you take opposite charges, what happens? There will be force of attraction. Okay, so that force depending on these particular charges will be considered under electromagnetic forces. Now here the point should be considered as under like charges there will be repulsive force. Okay, like charges will repel each other, so that's why it is considered. And regarding the opposite charges there will be the force of attraction. So here what is the important point? This particular electromagnetic force might be positive or nothing but attractive, or it might be repulsive. So both chances are there. So electromagnetic force might be attractive force or it can be repulsive force depending on the charges which we are considering. So that is regarding the electric force. If you separate these two, electromagnetic, so both words are there. So if you take electric field, we need to consider about the charges. If you consider the magnetic field, then we are going to see about the magnets. If you take the magnets, if you take two bar magnets, so there between south and north, so those two are opposite poles. So between those two, you will have the attractive force. If you take two same poles, suppose if you are taking two south poles at a time, between those two south poles, there will be repulsive force will be existing. So that's why the common point is that so the electromagnetic force might be attractive or it might be repulsive. Okay, depending on the case of application. Okay, now comparing to the previous strong nuclear force, this one is weaker. Okay, comparing to the previous strong nuclear force. And here the distances that should be considered these distances will be very longer when compared with the atoms. So in the first case we had seen about the nuclear force. Okay, regarding the nuclear force, what we mentioned here, these forces are inside the atom. But here regarding the charges or else between the magnets, the distance should be considered as larger. Okay, so that's why this force will be much longer distance range forces, okay, when compared with the strong nuclear forces. Now the next thing is about the weak nuclear force. Now we are not going to see much about this particular weak nuclear force. This is almost negligible thing regarding the previous two forces. Okay, now here regarding the nuclear decay, we are having this particular weak nuclear force. Okay, so now here as we mentioned it as weak, okay, when compared with the first two, and here the distances will be again very short range distances. Okay, now if you go with the fourth gravitational force, okay, now what is the first important point? This will be the weakest of all the fundamental forces. We are having four fundamental forces, but if you compare those things, the quantity or the amount, so this will be the weakest force of all the four fundamental forces. But it will act over very long distances. Okay, between objects, if you compare between the objects, so these distances will be larger, very larger when compared with the atom. Okay, the first one what we mentioned there, the strongest one is the strong nuclear force. And what is the weakest force? Gravitational force. But here these particular gravitational forces, even though those are weaker forces, the distances will be very long when compared with the strong forces. Okay, now where these particular gravitational force exist, it will act between any two pieces of matter, any two objects. Okay, between any two objects in the universe, this particular gravitational force will exist. Now this particular gravitational force will be always attractive. Suppose if you try to throw any stone into the air, what happens? It will definitely come back to the ground. So what is the thing there? The object will get attracted by the earth. Okay, so that is the thing. So here it is weakest, but it is over long distances. Next important point is that it is always attractive. Now where this particular gravitational force exists, it is between any two pieces, any two objects of matter in the universe. Okay, now depending on this particular force, we can explain the structure of the universe also, how the entire universe is going on. Okay, those things will depend on the gravitational forces only, how the planets are moving, okay, how earth is moving, okay, around the sun. So those things will be explained using the gravitational force. Okay, so these slides will show about the four fundamental forces. Okay, now let us go with the notes what we had in the concept of your notes. Now let us see some extra points. Okay, now here I'm giving the notes in this sequence. Okay, so what is the reason? In your textbooks you will see gravitational force, next as electromagnetic force, next as strong nuclear force, and last one will be the weak interaction force or weak nuclear force. So that's why I had changed the sequence. But actually, which one is stronger? This is the strongest force. Okay, the strong nuclear force is the strongest. Next one will come the electromagnetic force. This is the second. Okay, strongest. What is the third strongest? This is the third strongest. If you numbering this one, you will mark this as 1. Okay, mark this as 1. This will come as 2, and this one as 3. Okay, and the gravitational force will come as 4. Okay, but I wrote the notes here depending on your textbooks, the sequence in your textbooks. Okay, now let us see few more points regarding these 4 types of forces. Okay, now let us see about the gravitational force. Now, as we mentioned, it is the weakest force. Okay, it is the weakest force as a first point here. Now, the range of distance of existing these forces will be very, very long. Okay, long distances but weaker force. Okay, now the next point, as we had seen in the PPT, so it is always attractive. Gravitational force will remain always attractive. So where this particular force will be there, it is existing between any two pieces of matter or any two objects of matter. Okay, the same thing which we had seen in the PPT. Those points I wrote here. Okay, now what is the next point here? Depending on the gravitational force, we can explain the structure of the universe. Okay, so the entire universe is depending on the gravitational force. So we can explain the structure of the universe depending on the gravitational force. Now, the next point is going to give some equation here, a small equation that you had seen in your intermediate. Okay, now here we will take two different objects or two bodies. Okay, two bodies are there with some mass. Okay, some mass is there. Now these two bodies, let us take a body 1 here, first body, and the second body. Okay, second body is there. So two bodies are there, separated by a distance here. These two are separated by a distance capital R. Take this as capital R here. Okay, now consider the first mass as m1, some m1 here. Okay, next second mass as m2. Okay, now we are going to give a equation that you had already derived in your intermediate. Okay, so we need to give the equation of force, gravitational force. Okay, considering two different objects. The first object is having mass m1. Okay, second object is having mass m2, and these two are separated by a distance capital R. Okay, now let us see the next page. Okay, now depending on your previous expressions that you had studied in your intermediate, those points I am repeating here. Now the force will be proportional to the product of m1 and m2. Okay, and it is inversely proportional to the distance between the two objects. Okay, now these particular derivations you had already studied in your intermediate. Okay, so we are not going to use those derivations once again. Okay, we will take the derived equations directly. So just we are going to see only the fundamentals. So here I need to repeat one point. So in the applied physics, we will see all the fundamental points. So here we are not going to see any lengthy derivations. We will take only short derivations as much as possible. And in the upcoming semesters, you will be having the subjects like mechanics. Okay, now other subjects are there, strengths of materials. So under those subjects, we will see the extended explanations. Okay, so for those subjects, this particular applied physics is the introductory part. Okay, so we will see all the introductory part of those subjects which we are going to see in the upcoming semesters. Okay, that is the important thing you need to consider here. So we will take the short explanations only in your applied physics. Okay. Now, so let us take this as the first equation. Okay. So how you got the first equation here? You need to take out these particular proportionalities. Okay. Now you can write the equation as f is proportional to m1 into m2 by r square, capital R here. Okay. Now if you remove the proportionality, you are going to give a constant capital G. So capital G is a constant here. So this is a proportionality constant, which is known as the universal gravitational constant. Okay. The value you can see here 6.67 into 10 power minus 11 Newton meter square per kg square. Okay. So that is a value of Z, capital Z. Okay. Gravitational, universal gravitational constant or gravity. Okay. Now regarding the application, if we take a small application from your intermediate standard, okay. Now if you consider a body is there, some object is there, if you drop it freely from a height, okay, something, okay, if you are considering a freely falling body, then what happens to the expressions that you can see here? So the force acting on that particular freely falling body, okay, a body is there having mass m. Okay, m is the mass of this particular body. We are considering a body, okay, of mass m. M is the mass of this particular body. So what is the thing here? It is freely falling. So how it is falling here? It is due to the gravity, Earth's gravity. Okay. Now what is the force exerted on this particular freely falling body? That can be given by the Newton's second law. Okay. So what you can give here, instead of F equals to ma, so we have substituted the acceleration due to gravity as z here. Okay. ma, F equals to ma is there. So a has been replaced by g. What is the reason here? Because the body is freely falling. So you got the second equation here, F equals to m into g. Okay. Now here, what is the equation here? This is the equation of force, F, and the previous equation is also the expression for F, the force. Okay. So both the equations are same. Here it is F and here also F. So both the equations are equal. Equation number 1 and equation number 2 are equal. So that's why you will take the short consideration here. So you will consider the second mass as m. You substitute the second mass as m in the first equation. Okay. Now this is the first equation. This part is the first equation. Okay. This part is the second equation here. So in the first equation, what you did, you had substituted this m2 as m. Okay. Now what is the reason? You are considering the same body. Okay. So now from the substitution part, you can cancel these two, m and m. Now from there you are going to get the expression for g. Okay. The acceleration due to gravity, which is equals to capital G into m1 by capital R square. Okay. So here this is the expression for the acceleration due to gravity. Okay. Now that is a small introductory part that we had repeated depending on your intermediate standard. So we are not going to see anything other than these points. Okay. So no need to worry. We are not going to have much number of problem solvations. Okay. So in applied physics, we will see all the introductory parts and we will reduce the derivative parts, whatever the things are not required, because we are seeing only the introductory parts for the upcoming semesters. Okay. Now that is regarding the first force. What is the first force in this particular sequence? Regarding in your notes, it is a gravitational force. Now the second force in your notes, we wrote it as a electromagnetic force. Okay. Now from the previous PPTs what we had seen, it causes the electric and magnetic effects. Okay, it is the result of electric and magnetic effects. So that's why we are joining those two effects. Okay, so you need to separate here. This is electro, first part is electro regarding the electric field. Next one is the magnetic field, okay, or the magnetic field force. Okay, so both forces are included. So it causes the electric field, okay, as well as the magnetic field effects. Okay, so now these forces might be attractive force, okay, or else repulsive. So when it will be attractive force, if you consider two opposite charges or opposite poles, then you will have this particular force as attractive force. If you take similar charges or similar poles, then you are going to get this as a repulsive force. So what is the point here? So this particular electromagnetic force might be attractive or it might be repulsive depending on the point of consideration. Now in the previous case, in the gravitational force what we had considered, it remains as attractive, but here it will be either attractive or it might be repulsive. Now it creates interaction. Okay, this particular force will create interaction between the magnets. Okay, between the magnets. Okay, next, it is weaker, okay, when compared with the strongest nuclear force. So why we are considering the nuclear force as stronger means this particular force, the nuclear force, is making all the atoms together. If you consider the nucleus, it is holding the electrons and protons and neutrons together so that we can have the binding force and the substances will be stronger. Okay, so that's why the nuclear force is considered as the strongest nuclear force. So when compared with this particular strong nuclear force, this electromagnetic force is weaker. Okay, comparing with the strong nuclear force, electromagnetic force is weaker. Now regarding the ranges, so now here it is much longer range. This particular forces will be much longer when compared with the strong nuclear forces. Okay, because if you consider two magnets, okay, now here there are two magnets are there. If you consider this side as south pole and here this side as north pole, okay, there will be some force of attraction will be there, and here the distance will be very larger. Okay, the distance will be very larger when compared with the atom. If you consider the nucleus, okay, so the atom you cannot see with your eyes. What is the reason? It is very microscopical thing. Okay, but you can see the two magnets easily, and the distance here, if you compare with the atom, then it will be almost infinity when compared with the atoms. Okay, so that's why even though these forces are weaker when compared with the strong nuclear force, the range of these forces will be larger. Okay, so that is about the first two forces. Now let us see about the remaining two. Now the strong nuclear force, what we mentioned there, so those forces will exist in the nuclei of atoms. Okay, okay, so as we mentioned in the previous points, the strong nuclear force is confined to the nuclear forces. Okay, those are going to be inside the atom. Okay, now these nuclear forces will hold the atoms together. Now these forces are very stronger, okay, but they are very shorter range, because the distances inside the atom means you cannot see the atom. If you cannot see the atom means it is microscopical. Now inside those atoms, if you consider distances, it will be negligible, almost negligible. Okay, now the conclusion here, this particular force is stronger and this force is carried out by the particles inside those atoms. Okay, So these particles are known as the gluons. So don't worry about these words. We are not going to see anything much about these things. Simply note that the particles inside the atoms which are going to create the stronger forces, okay, those are known as the gluons, Gluons, okay. So these are the smaller particles, comes under the elementary particles, just like electrons, protons, neutrons, okay. So other words are there, other particles are there, like quarks, ketones, leptons, mesons, okay. So those other elementary particles are there. So under those things, we are going to use the gluons as a word representing the particles inside the atom. Now, what is remaining? The fourth one. Okay, it is a weak nuclear force. Okay, now these particular nuclear forces will be responsible for the nuclear decay. You might have seen certain equations. Some parent atom will be there. If you had seen your intermediate subjects, some particle parent atom is there. It will become as daughter atom. Okay, some other atom will become, and here you will have the emission of electrons. Some electron will be ejected from the atom. Okay, the electron will be ejected. Okay, from there you may get another particle. Okay, that is known as the neutrino. Some symbol will be like this. Okay, so we call those as the beta decay. So the particular forces emitting these things, okay, and these reactions, beta decay, under those beta decay forces are radioactive reactions. Okay, so there we are going to see the force existing, and which is regarding the nucleus, and this force will be weak force when compared with the other forces. Okay, other forces in the sense not regarding the gravitational force. Comparing with the strong nuclear force and electromagnetic force, this is weaker, but it will be stronger when compared with the gravitational force. Okay, similarly here the distance will be very, very short range. Okay, these are very short range forces. Now again the same point repeated here, it is going to cause the beta decay. Okay, now in converting the neutrinos into protons, these equations you might have seen in your intermediate. So those forces responsible for these beta decay or radioactive decay, okay, so those things will be depending on the weak nuclear forces. Okay, now let us repeat the points which we had covered today. Now what was the point here? We started with the force. Okay, so what is the force? We had defined the force as push or pull. What it is going to do? It is going to change the state of the body. Okay, now what are the effects of a body? It can change the speed of a body. Either it can increase or decrease the speed of the body. Next, what we had seen, a force can change the direction of a moving body. Next, it can change the shape and size of the body. Okay, that is regarding the introductory part of the force. Now the next point what we had seen, there are different types of forces. Okay, entire forces are classified into 4 types. Okay, we call these as the fundamental forces, okay, in the nature. And what are those 4 forces? Gravitational force, electromagnetic force, strong nuclear force, weak nuclear force or weak interaction force. Okay, now out of these 4, which one is stronger? This particular strong nuclear force is stronger when compared with all the 4. Next one will be the electromagnetic force. Okay, next one will come as the weak nuclear force, and the last one will be the gravitational force. Okay, Now next, what we had seen few more points regarding gravitational force. So here we had written certain important points depending on the explanation. Now what are the important points? Gravitational force is the weakest force of all the forces, but it is going to act over very long distances. Next point is that it is always attractive. Next, it is going to act between any two pieces of matter or objects in the universe. Next thing is about the universe. This particular gravitational force, depending on the gravitational force, we can give the structure of the universe. Thereafter, we had seen certain equations. So what might be the expression for the force that we had seen as the next point? Okay, for that we had given two equations. Okay, F equals to m1 m2 by r square. Now if you substitute the proportionality constant, capital G is the proportionality constant, we call it as the universal gravitational constant. Thereafter we considered a freely falling body of mass m. Okay, from there we got the expression of force depending on the Newton's second law. And from the comparison, what you got, the expression for acceleration due to gravity, small g, as g, capital G into m1 by r square. Now thereafter we had seen about the electromagnetic force. So what are the important points we had covered? Electro means it will be having the electric field, okay, related to electric effects. Next, magnetic field effects also will be there. Next important point is that this particular electromagnetic force might be attractive or repulsive. Okay. Next thing, the force will be existing between the magnets. Next thing is that it is weaker when compared with the strong nuclear force, but the distances of existing of these forces will be larger. Next, we had concluded with the remaining two. Strong nuclear force, okay, it is going to hold the atoms or the nucleus inside the atoms. And as we are considering the atoms and inside those distances, so the distances will be very, very, very small. But as the atoms are holding together by these forces, we consider it as a stronger force. Okay, when compared with all the other three forces, this is the strongest one. Because if we consider object, it should remain as it is. So how it is possible? Only when the atoms are held together. So how the atoms are together? It is depending on this particular force. Okay. Now what are the particles we are considering there? Which are the cause of this force? We call those as the gluons. Now what is the remaining force? It is a weak nuclear force. Okay. Let me check once. Okay. Now this is for today's class. Now remember, I am repeating the same point here. The thing is that we are going to see all the introductory parts. Okay, we will neglect lengthy derivations or lengthy expressions. Okay, so we will take only the things that are required as the introductory part for the next upcoming semesters. Okay. Okay, any doubts regarding the present topic? I think almost you had studied all these points in your intermediate. Please raise your hand so that I can unmute you if required. Okay, 103 said no doubts, sir. Okay. Now, what about your assignment? I told that you need to submit on Saturday, and I had shared the PDF material, handwritten material. I told that you take the topics and you can write referring any subject, I mean any textbook or any other thing regarding that is existing on the internet. So are you maintaining this particular running notes or not? YouTube. What is that YouTube? Okay, 103. So every time only I am seeing 103 or 1 or 2 members only. Why can't I can see other members? Why you are not active? So right now I am unmuting 103.
Hello, sir. Hello.
Hello. Cheppamma.
Can we refer for any other books for writing assignment?
Can you repeat your question?
Sir, can we refer for other books for writing assignment?
Okay, definitely you can refer anything.
Okay, sir.
Okay, any other members? So other students, you must be active.